Savino. I am a teacher at Highlands Middle School, and we came up with an alternative for the Pythagorean theorem. To remind you, the Pythagorean theorem tells us that in a right triangle, a squared plus b squared equals c squared. The way we get the length c is to get the square root of this number. Therefore, if a was 7, a squared would be 49. If b was 3, b squared would be 9. A squared plus b squared would give us 58. And length c would be the square root of 58. This is the alternative. In a right triangle with lengths of 7 and 3, I could do this in my head. I'll have a formula, but first let's do it using mental math. 7 times 3 is 21. 21 times 2 is 42. The difference between 7 and 3 is 4. 4 squared is 16. If I add these together, I get 58. And again, the length is the square root of 58. In any given triangle, I could set my table up like this. If the difference in side lengths is 0, I wouldn't have to add anything. 3 squared is 9, plus 3 squared is 9. Using the Pythagorean theorem, a squared plus b squared, I'd have 18. This would be the square root of 18. 3 times 3 is 9, times 2 is 18. The square root of 18. Whatever the difference is in the lengths of my sides, I simply take that number and I add the square of that number. It works every time. The formula for this is 2ab, a times b times 2 plus a minus b squared equals c. The reason this works, if you take 7 and square it and 3 and square it, and then add two numbers together, adding two numbers is the same as saying these two numbers times 2. I'm then adding the difference between the 7 and 3, which is 4, squared, because that's the part that's different. 7 times 7 is 49. 3 times 3 is 9. I have these two numbers and I add them together. If instead I just take the one number and multiply that by 2, that's almost there, except that I still have to account for the fact that 7 is 4 more than 3. And what I need is that squared. Once I add that extra part, I end up with the exact same number. The benefit of using the room 12 theorem, R12T, is that you can basically do these numbers in your head. For larger numbers, you would still want to use the Pythagorean theorem, do it on paper. But for smaller numbers, primarily what we're using in middle school, math, it's a good thing for the kids to know that they can do these numbers in their head. This is Debbie Savino at Highlands Middle School in Kennewick, Washington, with the Room 12 Theorem, alternative to Pythagorean theorem.